I'm going to add actually where the initial condition is no longer 0.
You want me to get it? Oh, you're good.
This will make a noise, this marker here, so I'll put it aside. Have people complaining that noise is tough to listen to. 12 volts. We have a switch here that's connected, and it opens at t equals to 0. It's going through a 2 ohm resistor. It's going through another 4 ohm resistor here. A capacitor of 1 farad. Notice I drew them that the curved side on the right, that means that's the minus, that's the plus. That's what that means when you see that look there, when they draw them that way. This is inductor of 2 Henry. This is a 1 ohm resistor on the top. And in the bottom we have a 3 ohm. And the question, find the current through the 1 and the 3. What is ICBO? I should have made lowercase because we are in time domain. Let me change it to lowercase. I forgot to bring erasers. You know I'm going to need them. Get a different blue marker. That really should be a lowercase ICBO. When you're in time domain, we use lowercase. Now the first thing I notice here for this, I could have took these two resistors and combined them and will not change ICBO. But let's look at the circuit for t less than 0 and get the initial conditions. Remember, we're assuming this has been sitting here for a while. And if it's been sitting here for a while, the capacitor reacts as what? Open circuit. And the inductor behaves as what? Short circuit. That's going back to a long time ago from circuits 1. To a DC source, and again, the reason to a DC source, because I equals C dV dt. I equals C dV dt. If there is no change in the voltage, that means your current is 0. For the current to be 0, it has to be an open circuit. And the voltage across the inductor equals what? L di dt. If there is no change in the current, the voltage has to be 0. For the voltage to be 0, that means it has to be a short circuit. So that's the reason why the capacitor reacts as an open circuit. The inductor reacts as a short circuit. The derivative of any constant is always a 0. So my circuit will look like this then when I look at it. 12, 2, 4. This is open circuit. This is short circuit. And I can combine the two of them, put them together, and make that a 4 ohm. And this is I. And I don't care about really I. What I'm looking for, what is the voltage across the capacitor? VC at 0 minus, plus here, minus there. And I'm looking for the current through the inductor, I sub L, as 0 minus.
Wouldn't the lowercase I be like either really low or 0 because the circuit can just complete through the short circuit and doesn't really need to go through the ohm, the 4 ohms.
Well, this, yeah, we'll short circuit that.
Yeah.
Yes. I'm just putting it there. That's what we have, you know? Now, what's going to happen, as Joe said, this is going to be short circuit, so that resistor is even gone. So when you look at it closely, this is what you see. The resistor is gone. This is I sub L here. And I can tell you that current is what? Better be 0. Why? It's an open circuit. Where is that current going to go? Where's it going to come from? And what's the voltage? VC, 0 minus. Nope. Not 0. This is VC 0 minus. It's between this end and that end. And where is that attached to? Right here. So that's the same as the voltage across the 4 ohm resistor. VC 0 minus is going to be the voltage across the 4 ohm resistor, which is voltage division 12 times 4 over the sum of them. 4 plus 2, which is what? 6? Is that 8 volts? So that's the whole idea to get my initial conditions. I need the current through the inductor is 0 minus, and the voltage across the capacitor is 0 minus. Now, I might have my sheet from last class. I might save one page of it. No. The one I gave you. Oh, there we go. I found it. And we said when we have a capacitor, an inductor, we can either replace the inductor with this or that. When you have a capacitor, we can replace it with this or this. So let's go through it and replace them. So the inductor, since the initial condition is 0, this source is gone. If I use that one, it's going to be SL. And the capacitor, if I use this one, is going to be 1 over SC plus to minus the voltage at 0 divided by S. So let's do the substitution. Now let's look at the circuit for t greater than 0. So this is just to get the initial conditions. So for t greater than 0, remember again, the current through the inductor at 0 minus is equal to 0 plus, which is 0. The voltage across the capacitor is 0 minus is the same as the voltage across the capacitor is 0 plus, which is 8 volts. So for t greater than 0, this is what my circuit looks like. This is going to open. What's going to happen to that 2 ohm? I'll come and clean it. It will look like this. And I can combine both of these and make it what, a 4 ohm? And this is I sub t. Because once you open it, this piece is gone. It looks like this. Nothing attached there. So I can just delete all of this. Since no current is going to be going through that because of the open circuit, I can even eliminate that 2 ohm resistor. So now my circuit will be, now I'm taking my time and I'm going slowly through it. 1 farad, 2 Henry, 4 ohms, and I'm looking for I sub t. And now this is my circuit in time domain. Let me change it to Laplace. I'm going to take that and convert it to Laplace. In Laplace, the resistor stays the same. Or S domain now. The Laplace of S is 1 over SC. And C happens to be 1. That's what? 1 over S. You also have, where's that sheet? You also have a voltage source for the capacitor, a voltage source with the value of V0 over S. What was my V0? Wasn't it 8? 8 over S. The inductor, SL, and that's what, 2S? There is no initial condition. I sub L was 0, so the source here is gone. I don't have to put it there. And this is 4. And now this is I sub, capital I sub t. Oh, I almost knocked the coffee again this morning. Not a good morning. If I just clean it a little bit there, 4, 1 over S, 8 over S, 2S, and 4, and this is I. I sub, not T actually, I sub S here, because we switch into S domain, right? So if I assign currents here, this is I sub 1, and this is just I. How many equations by how many unknowns I'm going to have?
2 equations.
I should have 2 equations by 2 unknowns. So let's do the first loop right here. 4 I sub 1 plus 1 over S I sub 1 plus 8 over S plus 2S times what? I sub 1 minus I is equal to 0. Let's collect like terms. 4 I sub 1, 2S, so 4 plus 2S plus 1 over S times I sub 1. I took care of this, I took care of this, I took care of this, minus 2S times I took care of that now, equals what? Negative 8 over S. That's equation 1. And let me do another mesh equation for the right side. 4I plus 2S times what? I minus I sub 1 is equal to 0. Clean that. 4 minus 2S times I sub 1 plus 2S times I is equal to 0, and that's equation 2. Again, I'm going to pull my calculator and use what Joe showed me last time.
Wait, sorry, just to the second equation, what loop are you doing that?
The right side.
So wouldn't that be 4I plus 2si minus I?
4I plus 2si. Yeah, that's I, not I1. Thank you. Before we get to it, good job. So that changes what to what?
So
Negative 2si sub 1. That changes that a little bit there. One little letter there will change the whole thing. Thank you. So that'll be what? 2s negative 2si1 plus 4 plus 2s times I, right? That's what it's supposed to be. Now let me go to my calc. Let me find where that button is. Here we go. New, two equations by two unknowns. And I'm going to write the first one. 4 plus 2x plus 1 divided by x. 4 plus 2x plus 1 divided by x, yep. I guess 17 over 2 says somewhere there. Next one, negative 2x. This is negative 4. And the answer is what? Negative 8 divided by x. The second equation, negative 2x plus, plus 0. So it really doesn't matter. The other one, 4 plus 2s, 4 plus 2x. And the answer is 0. And you said F5.
To solve.
I got a number, so something was right. I was putting numbers there. Clear. Let me clear everything.
Maybe that's
Yeah, that's what I'm thinking, because see how I'm putting numbers, but it's changing it. So let me try that. Quit. Am I supposed to clear that? Is there a button that will clear it? I said new. Maybe I said current. Two equations by two unknowns. Let me try it again. 4 plus 2s, 4 plus 2x, plus 1 divided by x. Yeah, it's putting numbers there.
Wait, what are you putting?
Yeah, you have to.
You have to do by each one. So you have to do 4. Oh, here, let me see.
Yeah, 4 plus, that's all.
Plus 1 over s.
Yeah.
Okay, yeah. And it gave you a number?
It gave me 17 over 2. So,
X, did you make x equal to something?
I don't know.
In the calculator itself?
so I don't know if there's a way to clear that. This is a new one. I'm assuming you put a new one, it just wipes everything that was there.
On mine, it's second memory.
Second memory to wipe it?
Well, then you have to do something.
Second entry. Where's memory? Oh, I see. Second memory. Oh, God. F1 to reset. All memories. Second memory. Do not interrupt. Second memory. F1 to reset. Reset the RAM. All RAMs. I go default. Default. So let's try it again now. New. Two equations by two unknowns. 4 plus 2x plus 1 divided by x. Yep, I got it now. Second one, minus 2. Oh, the wrong minus. Minus 2 2x, negative 8 divided by x. The next one, minus 2x, 4 plus 2x, and 0. And F5 to solve it. I'm only interested in really I, right? So based on my calculator, this is what I get for I. Because so for I get I equals, as a function of s, I don't care about I sub 1, negative 8s over 8s squared plus 9s plus the 2.
I didn't get that.
I got it.
Is that what you got? What was up there?
Yeah.
I must put it in wrong.
Now, if you divide everything by 8, was that a negative, the first one, or positive? I got a negative. Did you get a negative?
Yep.
Okay. So if you clean that, you're going to have what? Negative s over s squared plus 9 over 8s plus 1 over 4. If you divide everything by 8, top and bottom. That's a quadratic. Now I can try to factor that. Let's just solve it so I can factor it. Minus 9 over 8 plus or minus the square root. 9 over 8 squared. What's 9 over 8 squared? 9 squared is what, 81? 81, 8 squared is what, 64? Minus 4 times A times C. All divided by what? 2A? That's 4 over 16, or 64 over 16, isn't it? This is 4 over 4, which is 1. So 81 minus 64. What's 81 minus 64?
17.
17 over 64 divided by 2. So they're really real answers, just decimal numbers. So let's do the calculator. Let's have the calculator do it for me. So my first solution is going to be what? Negative 9 divided by 8. Oh, wait.
That's right.
No, my calculator is doing some crazy stuff. Clear. Here we go. Negative 9 divided by 8 minus the square root. Where's the square root? Where'd you go? I see it. Square root, yep, of 17 divided by 64 divided by 2, and give me the decimal value. Negative 0.41. The other answer, it's negative 9 divided by 8 plus the square root of 17 divided by 64 divided by 2, and it's negative 0.15. So you can write I sub 1 now, or I as a function of s, to be k1 over s plus 0.41 plus k2 over s plus 0.15. That means when you look at here, it's going to be negative s when you write it, over s plus, that's why I went to this one, 0.41, s plus 0.15.
I got negative 0.304 for the first one.
What'd you get?
Negative 0.305.
305 in the second one?
I haven't checked it yet.
I believe your number is probably more accurate than mine. Can somebody else verify the number? with the minus. He said 305.
Doing it right now.
And the other one I got, negative 0.82.
Negative 0.35. You said 35 or 305?
Negative 0.82 and the other one's 0.305.
So negative 0.31, negative 0.82. You're probably more accurate than me. I'm horrible with the calculators. So this will be then 0.31, 0.82. I got to change the other one. So this is 3.1 and that's 8.2.
That's what I got too.
Thank you. So 0.31, 0.82. Let's find K1. K1 is going to be negative S over S plus 0.82. You want it when S equals negative 0.31. .31 plus 0.82 in the bottom is what? 1.13. Divide them. 0.31 divided by 1.13. 0.27. And K2 equals negative S over S plus 0.31 when S equals negative 0.82. .13. Oh, that doesn't seem right when you plug it in, right?
That would make it.
Yep, that won't be an adding. I just looked at it. That's a negative, that's positive.
Yeah.
Oh yeah, wake up today. Let's see what that number. Negative, I hate calculators, I really do. Negative 0.31 plus 0.82. That's 0.51. First, I can't see him. .61. And the other one, what's negative 0.82 plus 0.31? Negative 0.51. Negative 1.61. So if I did push the right button again, verify all these numbers.
So where are the negative S's coming from again?
What makes this one 0? Negative 0.82. What makes this one 0? Negative 0.31. Negative S? Oh, on the top. I got a negative, unless I did something wrong.
Gotcha.
Assuming that's correct. Again, verify the math. So once you have that, you know what K1, K2. So we solved it and we found I sub S as a function of S now, if my numbers are correct. I used to be decent with the 89, now it looks like something from outer space. I forgot, it's been a while since I used it. And now I'm going to change it, finally change everything to I sub t. I as a function of t, 0.61 e to the negative 0.31 t minus 1.61 e to the negative 0.82 t and u sub t, because this calculation for t greater than 0. So my calculation were based on t greater than 0. That's why the u sub t. This is for t greater than 0.
I apologize if this is a redundant question, but what is the main difference for why we're adding in these sources now, prior to like when we were just using the use of t's for the other sources?
What do you mean adding these sources here?
No, not the use of t's, but when you're going back to the original circuit and you're adding like the 8 over s
Oh, that's the Laplace.
source.
The Laplace, the derivative,
Like,
right?
Is that like an optional thing to do?
No, not an optional. No, you have to. The previous one, all the initial conditions were 0. Remember, the derivative of the Laplace, the Laplace of the derivative. Where's my book? When you do the Laplace of the derivative, I'm sure we have Laplace derivative, the Laplace of the integral here somewhere.
Oh, yeah.
It should be somewhere here, the Laplace of the derivative. Is there a derivative here? Where's derivative? Here with Laplace derivative, right in the bottom. The Laplace of the derivative of the function. Can you see it? It's s times f of s minus f of 0. The Laplace of that. That's just the derivative. So when you have I equals c dv c dt, or v equals L di dt. And you want to do the Laplace of that. Let me take this. The Laplace of this v over s. This is the L. What's the Laplace of the derivative? According to this one, it's s times f of s. So it's s times I of s minus, now again, you're talking about the derivative. You want to take the value of this function as 0. I of 0. That's the Laplace of it. So you multiply it through, you'll have what? Ls I sub 0 minus L I of 0 minus. If you were doing this one, the Laplace of that, that's the c in the front. What's the Laplace of this? S times v of s minus the voltage at 0. Now you multiply it by c, you have cs v of s minus c v sub 0. If you're doing the current here, and again, the current, they'll be in parallel. So if you look at my circuit for that, when I did it, this is I for the capacitor, right? To add current, they must be in parallel. Where is my capacitor? This is my capacitor. Notice SC, see how that in parallel with CV0. But look at the direction of this one. This is coming down, this is going up because it's a minus. You have to subtract, you have to reverse the direction of it. We define the current down, that means coming down, and this is going up. That's why it's subtraction. Look at the voltage here. V equals Ls I sub I S, not I sub 0, I sub S. This will be SL, you multiply it by I, you end up with V equals this current times SL, plus to minus. Well, minus is minus to plus, but look what they did. They put negative Li sub 0. So that's why we add these, because the initial conditions. In the previous two problems we did last video, the initial conditions were 0, so I never had to deal with them.
It's because you start with a closed circuit, right? Like
Yes.
Yeah.
Sometimes you have actually sources before and after. You know, I'll see if I can find one.
But isn't the last circuit technically closed as well? they add unit step functions.
Let's see if I can find one where you have sources. Nope, initial conditions 0 here. Ah. Keep clicking the wrong button, I keep closing things. Nope. No. I don't have an initial condition. Try and find something in the back where initial conditions are. No. No. Not many problems actually. I'm not finding anything where the initial conditions are not really 0. I mean, I can make one, but God knows what the expression going to be. I was hoping I can find one where it's nice, it's going to work out beautifully, so I'm not going to end up with an expression that looks like, oh my goodness, what did we do? Okay, let me try another one. I have no idea. I can't find anything, so I'll swing one. I'll modify. I'm taking a problem here, but I'm making little changes to it to see what will happen. And your guess is as good as mine what's going to end up with this. 10 volts here. 1 ohm. We have a switch that's closed right now. It's going to open at t equals to 0. It's going to go to, oh, its catch is going down, but let me make it look a little bit nicer. Not from the dot. Let me push it to the right a little bit there. Then bring it down. This is 2. 1 Henry, 1 farad, and let me actually have fun with this. Here's where my fun comes in. We have another switch here, close at t equals to 0. And this is 1 ohm. Well, we lucked out with one of these here. Again, for t less than 0, here's what we have. 10, 1, 2, inductor is a short circuit, capacitor is an open circuit. That switch is actually open. So there's really nothing going through that resistor. So if you want to make this an open circuit, the capacitor will look like this. Very similar to the previous one in terms of the initial conditions. I forgot what the question is. Where is the question? I don't know. Let's find the voltage across the capacitor. It doesn't really say. I'm quickly trying to peek. What's the voltage across the capacitor? V out or VC. What's that voltage? Now look at that. What's the current through the inductor? 0 minus. How much current? What is the current going to the right? What's the current through the inductor? 0 minus. Going this way. Better be 0. Where is it going to go? It's not going to jump over that hole to get to here. It's not going to jump over that. Open circuit, it dies. Boom, nothing goes through it. What's the voltage across the capacitor? 0 minus. Try again.
Two.
The voltage across the 2 ohm. They're in parallel. Which is 10 divided by 2 over 3. What's that, 20 over 3? So the whole idea of looking at the circuit for t less than 0 so I can get these numbers. And again, here's good news for us, because ideally you hope, you're praying initial conditions are 0. It makes your math easier. Just the math. There's nothing in the circuit. Well, because this will be a 0. This will be a 0 if the initial conditions are 0. It's not a 0 here, but I'm going to use that value. So let's look at the circuit for t greater than 0 now. The switch is going to open. This is gone. This piece is gone. That switch closes now. And again, this is V out. In case you forgot, the initial current as 0 minus is what? 0. The voltage across the capacitor is 0 minus. We said, what was it, 20 over 3? If I forget about it? Yeah. So that's all I need from this, just to get these two values. Then I'm done with it. It can go away. I1, I2. This is I1 here on the left, I2 on the right. I can do KVL. I find KVL mathematically it's easier than nodal analysis because you're not dividing tons of fractions. So that's why I stick with that. I should use lowercase I because I didn't change them yet to S domain. I'm working on that. Now let me change them to S domain. The resistor stays the same. The inductors SL. L is 1, that's S. And the initial condition, which is 0, notice the inductors SL and negative Li sub 0. Well, if that's 0, this is 0. So nothing else. The capacitor now, 1 over SC, C is 1. 1 over S, and a voltage source of what? V0 over S. Can you see it? V0 over S. What was V0? 20 over 3 divided by S. And V out is actually the voltage across both of these, right there, from top to bottom. That's what V out is. because that's the voltage across the capacitor. Both of these are the capacitor combined. Now this is I sub 2 capital letters, and this is I sub 1. Again, if I clean it, S 1 over S, what's that, 20 over 3S?
Yep.
I sub 2, I sub 1. V out is right here. Yucky. Let's do the first KCL. This will be ugly. The reason I'm saying it will be ugly because to find V out, once I find I sub 1, I sub 2, I'm going to do what? Subtract them? Do I really want to do that? That might be ugly, you know? Mathematically, I'm just looking ahead. Nothing wrong with what we did here. This is okay. Nothing wrong with it. It just makes it ugly. Well, let me think of a different approach then. What will happen if I decide to use, instead of KVL, KCL? Let me just take a peek at it. I can take these two, combine them together, and make it what? 2 plus S. They are in series. One. Wait a minute. Where's my cheat sheet? If I use a capacitor, so this is going to be 1 over SC, and that will be what? C times V0. 1 over SC with a current source pointing upward, with the value of that CV0. That might be actually easier. It might be mathematically, because how many unknowns do you have there? One. So nothing wrong with this, but I'm looking ahead. This will give me two equations by two unknowns for I sub 1, I sub 2. Then I got to subtract them and multiply that by 1 over S and add to it this. That might be a lot of work. So instead of putting a voltage source here, which I could have done, I said if I did a voltage source here, I'm going to have another node here. Now I'm going to have two equations by two unknowns. Why not make it in parallel? They're all in parallel, will be easier.
That doesn't alter V sub naught at all?
What is what?
That doesn't change V sub naught?
Nope. V sub out still across the capacitor. That's equivalent to the capacitor. All of this is if you decide to put them in parallel or in series.
Equivalent. Yeah.
Yep, that's the equivalent. So this is really what the capacitor is, the equivalent value. So now I only have one unknown. If you assign current any direction that you want to go, you know what? I think the current's going to go this way. The current's going to go that way. That might be easier mathematically. So that's the reason why I decided to switch this one from this to that. I think my math will be easier. Both will give you the same answer. Both will, if we do it right, both will give us the correct answer. Let's look at that. The current N, which is what? C V0 equals the current leaving. I sub 1 plus I sub 2 plus I sub 3. I just happen to know what C and V0. V0 was what? 20 over 3. And what is C for that circuit? How big the capacitor was? Was it 1 farad? Where'd you go? 1/3. So 1 times 20 over 3 equals, what's this current? Isn't that this voltage, which happens to be V out, divided by 2 plus S? Plus, what about I sub 2? V out divided by 1 over SC plus V out over 1. How many unknowns do you see? 1 unknown. This will be what? SC is 1. So 20 over 3 equals 1 over 2 plus S plus 1 times V out. Now if you want to find the LCD, you can make this over 1 and find your LCD, make it look a little bit nicer. I don't need to use a calculator for that. 1 over 2 plus S, that's the same as 1 over S plus 2. If I put S plus 2 in the bottom of this one, I got to multiply the top by S plus 2. S times S is S squared. I think that's 3S. And 1 times 2, which is a 2. Again, what I did, S plus 1 times S plus 2 for the LCD. Try to write this one like that. That's S squared. 2S and 1S is 3S, and that's a 2. So 20 over 3, add 1 to it, S squared plus 3S plus the 3. So what's V out going to be as a function of S? (20 times S plus 2). I can go over 3 here. The whole thing divided by S squared plus 3S plus the 3. Time-wise, yep, we're doing okay. So let's factor the bottom and see if we have complex roots. If we have complex root, that's minus 3 plus or minus the square root of what? 9 minus 4 times A times C, that's 12. Is that J the square root of 3? So that's negative 3 over 2 plus or minus J the square root of 3 over 2 if you want to leave it. So you can write V out over S. Might be easier if I use numbers instead of leaving it the way I left it there. But this is S plus 3 over 2 minus J the square root of 3 over 2 times S plus 3 over 2 plus J the square root of 3 over 2. Complex roots, which I can factor it to what? K over the first one. That's a minus. Minus J K conjugate over S plus 3 over 2 plus J the square root of 3 over 2. And if I know what k is, we are done. So let's find k. How do we find k? Notice k is sitting on top of the minus here, so this piece is gone. So it's going to be 20 over 3 times s plus 2 divided by s plus 3 over 2 plus j, the square root of 3 over 2, when s equals, what makes the bottom 0? To me, it looks like negative 3 over 2 plus j, the square root of 3 over 2. You agree with that? That makes this one, this is gone. Notice k is sitting on top of that. That piece is gone from this expression. And you want to find the value of that when s equals, what makes the bottom 0? It has to be negative 3 over 2 plus j, the square root of 3 over 2. So plug it in, and let's find k. So that will be 20 over 3, s plus 2. Let's add 2 to this. Negative 3 halves, when you add 2 to it, what's that? Plus 1 half? And in the bottom, there'll be 2 of these. Because the negative 3 halves will cancel the plus 3 halves. You'll have 2 sets of these that will cancel the 2 in the bottom. So let's see what that number is. And definitely I'm probably going to need help with this on the calculator. So somebody double check that just to make sure I don't screw that one up. 0.5 plus, what is the square root of 3 divided by 2? I should put parentheses here to say that's the I portion. I, the square root of 3 over 2, divided by I, the square root of 3. I got a syntax error.
You gotta add another parentheses.
Oh,
I got something.
I got 3.33 negative 1.92j.
Yep,
Can we change it to phasor?
sure.
I don't know how.
I got you.
Yeah, if you go into mode,
Mode,
yeah,
Got 3.84.
you go down to,
polar, rectangular.
yep. Oh wait, not that one. Go right below it.
Spherical.
No, click escape.
Escape now.
Yeah, no, if you, no.
Oh,
Yeah,
You got it.
I don't know, that might work. No.
Yep.
Yeah, I think it's another setting that you use.
so what do you got? What do we have for an answer? I'll let you do it. You probably.
3.85.
What is it?
3.85.
3.85.
Angle negative 30.
Perfect. That's all I need to know. So now we can change it. Remember with the solution, when you have complex like this, we said last time if you have k over. So k will have an angle of theta. So you have k over s plus alpha minus j beta plus k conjugate, that would be k angle negative theta is the conjugate. The solution to that, we said, is going to be what? As a function of time, let's say v sub s, v sub t, this will be what? 2 times the absolute value of k, e to the minus alpha t, cosine what? Beta t plus theta. So if I use that here, my solution is going to be 2 times the absolute value of 3.85, which is a positive number, e to the negative, alpha is 1/2, cosine beta. Beta is the square root of 3 over 2, and we get the negative 30. And 2 times 3.85, what's that? 7.7 maybe? 3.85 times 2, 7.7. E to the negative 0.5t if you want it. Cosine, I can leave this the way it is, the square root of 3t divided by 2 minus the 30 degrees. And that's u sub t because that's only good for t greater than 0.
Wait, where's that 1/2 coming from?
Alpha.
Is that 3/2?
3/2. 1.5, 3/2, thank you. I got excited there. E to the minus 1.5t cosine. That's alpha and this is beta. It wasn't that bad. When you make changes to a problem, you expect it to be ugly. It wasn't as bad as I thought it's going to land.